Hi everyone, it's me again, Tirsa, and this time we will learn about Zener diode as voltage regulator. Okay, but before, as usual, log into your account first, then wait. And then go to Physical Sciences, and then scroll down until you find the solid state physics, and then Zener diode as voltage regulator. As usual, there are these things that we've seen in earlier videos. It's just the same. And then to start the simulator, we go here. Then enable the flash player, allow it, and then just load the page, and then we'll wait until the simulator comes out. Okay, so here is the simulator, and then for now, I'm not gonna explain to you what are these because I already explained it on another video, which is characteristic of Zener diode. So for now, we're just going to jump into the simulation. Okay, to start the simulator, remember to always read the procedure. Because if you read the procedure, you know what to do and what not to do. And for first, in the beginning, we're going to connect the node over here. I'm sorry about the noises. We're just going to ignore them for now. And focusing here. One more thing, and then boom, the insert key button is already available, and then now we're going to start. There are two things that we're going to simulate here. First, our line regulation, and then the second one is load regulation. So we're going to start the line regulation. First, insert the key, and then choose the Zener diode to start the experiment. But this time, I'm just gonna use this, and then insert the series resistance value. I'm gonna put 1000, and then fix the load resistance value by using load resistance slider. Okay, the load resistance, I'm just gonna increase it from 0 to 5000. So, 5000, and then change the rheostat value from maximum to 0 by the interval of 100. Okay, we go to 0, and then this is the value that comes out. As you can see here, voltage across series resistance, or VS, is 6.4 volt, and then the current through series resistance is 6.4000 milliampere, and then the current through load resistance is 1.1200 milliampere, and then the current through Zener diode is 5.2800 milliampere. And also you can see over here there are 12 voltage. This is the voltage in, and then here is 5.6 voltage is voltage on the first resistor. Okay, after you put all of this value in a table, now we're going to change the rheostat value from 0 to 100. Okay, it is hard. Okay, and then as you can see here, the voltage in is 10.64 volt, and then the voltage on a first resistor is 5.599 volt, and then the Zener voltage is the same value as voltage on a first resistor here. Okay, and here is the result from our simulation line regulation, and then as you can see here, the RS is 1000, RL is 5000, and then this is the voltage in, the voltage loaded, the voltage on the first resistor, and then this is the delta V in. The result is from 10.64 minus 12 equals to this, and then for this is 9.35 minus 10.64 is equal to this, and then the rest is just like that. Same with delta V null, and then the percentage is 53.333%. The value you can get from the equation of delta V null divided by delta V in times 100, and this is the graph. The relation between voltage input and voltage on loaded resistance. Okay, next we're going to simulate the load regulation, and then first 3 steps are same as above. Above means the line regulation that we already did before. So insert key, choose Zener diode, and then insert the series resistance, and then fix the rheostat value to get 12 volt at regulator cross rheostat. We're going to fix this until we find 12. Okay, there we go. It's 0. And then next is change the load resistance with the interval of 100 or 1000 ohm up to maximum range. Okay, so the load resistance, but for this I'm going to use the interval of 500, not 100 or 1000. After the value comes out, we'll put it on the table, and after that we're going next and increase the load resistance from 500 to 1000. And then as you can see here, the voltage loaded or Zener voltage is 5.6 volt, and then the voltage on the first resistor is 6.4 volt, and then the input voltage is still the same, 12 volt. And after that we're increasing it to 1500, and as you can see here, the value is remain the same. We're increasing to 2000, and still the value is the same, even when we're increasing the load resistance to the maximum, which is 20,000, but still the value isn't changing at all. Okay, so here is the result from load regulation. As you can see here, the voltage input is 12 volt. The voltage on the first resistor here, the resistance loaded is here, and then this means voltage loaded is equal to Zener voltage, and here is VNL is the output voltage when there is no load resistance, and then the VFL is the output voltage when the load resistance is maximum. The load resistance here, the equation is VNL minus VFL divided by VNL times 100. Okay, on the right over here, you can see the graph between the loaded resistance and the voltage on series resistance. And that is all for today. Thank you for watching.